Okay, class, sorry this is so late, but let's go ahead and go over the first 6 problems on this page. This is all solved by graphing. Remember, you have to put in the y-intercept and then the slope. Y-intercept, slope. And here are the answers. I'm just going to briefly go through. Alright, number 1, the intersection is at 1, 2. Number 2, the intersection is at negative 1, 3. Number 3, the intersection, well, there is no intersection. So because they are parallel, if you notice, they both have a slope of 3/4. Okay. Notice up here, one of the things I did was I went ahead and solved the problem. I took the problem here, I added y to both sides, I then subtracted 4 to both sides, and I got this equation, y equals 3/4 x minus 4. Notice they have the same slope. And because they have the same slope, there's not going to be any intersection. So because of that, it's no solution. All right. Number 4, if you look down here at the bottom, when I solve this equation, basically when I solve it right here, I subtracted 3x from both sides, and that gave me y equals negative 3x minus 4. It's the same equation as this right here. Therefore, I only need to do the line once, and because one line overlaps the other, it's going to be infinite solutions. All right, number 5, they intersect at negative 2, negative 2. And number 6, because there's no y-intercept, if you notice here, I'm going to put plus 0, plus 0. That's the y-intercept. Therefore, the intersection is at 0, 0. Okay, on these problems, 7 through 12, it's all about substitution. Notice I've circled the variable that we've solved for. So I'm going to plug in y right here for this y. On number 8, I'm going to plug in this y over here, and so on and so forth. Now, on number 7, the answer is 1, 1. Basically, I solve for the variable x. I added x to both sides right here, and then x is equal to 1. I then plug it back in for this x right here, and I get y is equal to 1. On number 8, I did the same thing. I came out with the answer being 2, 6. On number 9 was a little bit more work, so I put both, since they were both equal to x, I put them both equal to each other. I then added the 2y to both sides. And then when I added the 2y both sides, it cancels from this side, and 2y plus 1y is 3y. I brought down my negative 5 equals 1, and then I added 5 to both sides, and 3 times 2 is equal to 6, therefore y is equal to 2. I then plugged it in right there and got 2 minus 5, which x equals 3. On number 10, when I plug it in, what happens is the x's cancel out, because 3x plus negative 3x is 0. Therefore, I'm left with 4 equals 10, and 4 will never equal 10, therefore it's no solution. On number 11, sort of the same thing happens, but this time my x's eliminate, and I'm left with negative 6 equals negative 6, and negative 6 will always equal negative 6, therefore it's infinite solution. And then on number 12, I came up with the intersection of 2, negative 2. Okay, on this page, 13 through 18 is basically elimination. So you're looking to eliminate. Well, if you notice here, when I add straight down, I can eliminate the two y's. That leaves me with 4x equals 4, and therefore x equals 1. I then plug it into the top equation. All right, so when I plug it into the top equation, I replace x right there with 1. So 1 plus 2y equals 7. I solve for y right here, and I get y is equal to 3, and my intersection is 1, 3. When I go to number 14, I do the same thing. I look to add straight down. When I add, the x's eliminate. Therefore, I'm left with y plus y, which is 2y. And 2 times something is equal to 4, therefore y is equal to 2. I plug it back into one of the equations, and I solve for x equals 1/2. Therefore, my answer is 1/2, 2. All right, number 15. On number 15 was a little bit more challenging. I can't add, so what I saw that I could do was I actually can subtract. Well, 3x minus x is 2x, y minus y cancels out, and 2 times something is 8, therefore x is equal to 4. I plug it back into the bottom equation because that seemed to be the easiest, so 4 plus something is 12, and that something is 8. So the intersection is 4, 8. Now, when I go to number 16, something this just happens to be a little bit more in depth. Notice on the top one, I multiply the top by positive 2, and you have to multiply everything in that sequence by 2. I get 8x minus 2y equals 12. Well, notice I didn't do anything to the bottom equation, so when I add straight down, my y's cancel out, and I get 11x equals 33. Well, then x is equal to 3. I then plug it back into this second equation, and I get 3 times 3, which is 9, and I solve for y, and y is equal to 6, giving me the solution of 3, 6. Now, on the last two, on the number 17, it is real easy. I added straight down. I got y is equal to 0. I then plug 0 back in, and I got x is equal to 0. So my solution is 0, 0. On number 18, I had to do a little bit more work on this one. So what I ended up doing is multiplying the top one by 5 and the bottom one by negative 3. Notice what happens is when I multiply it by this one right here, that came out to be negative 15. When I multiply the negative 3 times the negative 5y, that came out to be positive 15y. And so when I added straight down, those two eliminated. When I added the 20x and the minus 9x, that gave me 11x. And 11 times 8 is 88. Therefore, x is equal to 8. And I repeat the process of plugging 8 back into one of the original equations and getting 7. So the answer is 8, 7. Okay, in this last section, I'm just going to quickly go through it. I'm going to pinpoint a couple of things. Notice, dashed line, dashed line. Remember, y is a horizontal line. Therefore, y is equal to 6, y is equal to 3. The shading is y's are less than 6, so it's going down. Y's are greater than 3, so it's going up. So the intersection would be this shaded area right here. On number 20, notice x equals 7. Well, I don't have a 7 on the graph, so I basically, if you notice here, I went ahead and, if you look right here, I created a y equals 7. Okay? Now, let me go ahead and erase that. I created x equals 7, and then I shaded to the left. Now, the double shaded region happened to be this area right here because y is equal to 2 is a straight line, and I shaded up. And that is my solution area. On number 21, notice it's just y is equal to negative x minus 2. I kind of had to solve the equation. So in doing so, I solved the equation right here. And then I had to solve this equation. So when I solved both equations, I simply graphed them. Remember how I told you to put your shading or start your shading from the y-intercept? This shading went up, this shading went down, and therefore the solution area happened to be this double shaded region right here. All right, on the next row down, number 22, here's your answer. Remember this; they're both dashed lines. On number 23, the shading is away from each other. If you notice here, this shading went less than negative 3. This shading went greater than positive 5. And therefore, since none of the shading region overlap, it's no solution. And then on number 24, the double shaded region happens to be right here in this little pie area, and that's the answer.